Okay, seems to be going. Part 2. Okay, thank you, Jan. Okay, so, as Ramsey already noticed, the 3x's, the negative 3x and the plus 3x will cancel. The 7 minus 7 will go to 0.
You said that if everything that's not an h doesn't cancel out, then you did something wrong, right?
Bingo, that is correct. So I have negative 3h over h. If everything that's not an h on top doesn't go away, you've made a mistake on all the problems we're going to look at here.
This is like rotated.
That's still 0 over 0.
Well, yep, but now I can cancel out the h's.
Limit.
And it's the limit as h approaches 0
solve.
of negative 3. And what did I say the limit was if there's just a number here? And the variable goes down.
C.
Boom.
The number.
Mr. Belvo?
Yes.
You know what you need? One of those stamps.
I
that
do need a
already
stamp that
say
just
limit
says limits.
H equals.
That would be amazing because this shows up a lot. Okay, now.
Why did they come up so much? If they couldn't.
Well, now think about
delta x. They couldn't.
I know. Now think about this for a minute though. Forget the notation for a second. Think about what we just discovered. The h went away. The x's went away. The answer is always negative 3. And this is the point where now you're supposed to plug in x equals 1, but there's no x to plug it into. So what this means is for this function, the instantaneous rate of change is always negative 3. Does that make any sense?
Yeah.
You mean the slope?
Because if there was an
Because the
x,
slope
then
is
you would
negative 3.
let the dog off the leash, right?
Yep. Here's what just happened, and there's a shortcut for this one. Okay?
Isn't it always going to be the slope if it's a line?
Ramsey's got it.
Yeah,
I was
This-
wondering why you.
Why was I bothering to do all this? I was waiting to see if someone had interrupted me. I might have stopped. You hit 7. This is a line with a slope of negative 3 and a y-intercept of 7. Does it ever change direction? No, it doesn't do anything funny. It's always going down at a slope of 3. Its average rate of change is always negative 3. Its instantaneous rate of change is always negative 3. If you see a line, there is no difference between the derivative and the slope. It won't change. But that's only true of a line.
Are we only going to do lines?
No.
What about sine waves? What
Pardon?
about sine waves? Since they're perfectly consistent, it's the instantaneous velocity at different instants. Like
Yes. A sine wave, what a sine wave does is repeat over and over again. So if you know the derivative of a sine at pi over 4, then you know it at, I'm heading 360 in my head, then you know it at 5 pi over 4. You know it at 9 pi over 4 because it keeps repeating. So once you find a slope of a tangent line at one place on a repeating function, you know it at each period repetition after that. That does come in handy later, believe it or not. Not this year, but next. Okay, this one won't take long. New example. F of x equals
Jeff, can you hold this?
x
I'm gonna write this
squared
down.
minus 6. Okay? Here we go. Excellent. Good idea. With the wide angle lens, it might actually work that
Hey, it does!
Yep.
Okay, I love that lens. Okay, f of x equals x squared minus 6, and the point I am interested in
Thank you, wide angle lens.
is going to be x equals 3. I'll go ahead and tell you that there will be no trick ending to this one. You will have an x in your answer and plug it in. So,
Parabola with a shift.
yep, it's very good. Guys, the more you remember your basic functions, okay? Like Ramsey just said, this is a parabola with a vertical shift.
Downward.
Can give you a hint of what it looks like, of what you can expect.
But I wasn't sure if it was still going to be.
Yep. So f of x plus h then is x plus
Are you always going
h.
to give us x?
I'm sorry?
Are you always going to give us x?
If I'm asking for the slope at a point, yes.
Okay.
If I'm asking for the general derivative formula for that function, then no.
Wait,
And you'll see the difference. You'll see the difference in a minute.
Now you're using H as two things.
What?
No, h
No,
is
it's
still
the
my
same
f
thing.
of x plus h.
But H is
So the-
H is vertex form H.
Yes,
not-
that's true. I'm using it. This h means delta x. This does not mean the h.
So that doesn't mean shift.
This does not
But
mean
the h
shift.
would be
No.
on the
But then
outside
why is it
anyway.
inside? Oh yeah, the K is on the outside.
Well, it does because remember.
He said he told us.
No, that's a very good point. And I want to make sure the notation is. Remember, h was delta x. Okay, so you've got an x here, right, Janan?
Yeah.
And then you go further down any function, and you've gone x plus some more x. Another way to look at
Some
delta
more.
x. Okay? So if I have any function, I have this point, which corresponds to f of x, and I have this point, which corresponds to f of x plus delta x, which we're calling h. So it does work. Think of this as more like x sub 1 and x sub 2, and less like a counterintuitive left and right shift. Because we're not moving the function, we're moving to a point further on the same function. This is like,
it looks like x
yeah,
plus k
yeah, no,
squared.
I'm thrilled that you remember the vertex form of a parabola that well. You're onto something, it won't help you solve these problems tonight, is the shortest answer I can give.
So the answer is 1, right?
Hang on, f prime of x is going to be the limit as h approaches 0 of f of x plus h squared minus 6 minus x squared minus 6 over h.
And then it's x squared plus 2xh.
Yep. You gotta do all the foiling, very
plus
good.
h
Yeah, that's
squared.
what
X squared plus,
H
2hx.
plus H squared.
very good, plus h squared.
Minus 6, and then you minus
Minus x
X
squared.
squared minus 6, and then you cross those out.
So it's plus, yeah, it's plus 6 when if you distribute it.
Yeah.
It's subtraction to both, but I think I know what you meant. Minus x squared plus 6 will disappear with the x squared and the minus 6, and everything left has an h in it. So now we're looking at the limit as h approaches 0 of 2hx plus h squared over h. Can't let the dog off the leash yet,
Because
No.
you can't, yeah, you're not talking.
but I will show this step especially for Parker and Megan who weren't here.
Cross multiply?
Well, if I factor the h out, top and bottom, if I factor an h out of the top, I'm left with 2x plus h.
So it's going to be
Cancel these out. Let this remaining h go ahead and reach 0,
And then you cancel them.
and the answer is simply 2x.
Wait, you can let it reach,
Mr. Bell,
Yes.
is the
Wait,
derivative always
Oh,
going
you
to be
plug in zero
one
for
exponent down
Well, the one
than
that is
what the
zero,
function
so
is?
just-
For polynomials, yes. Good eye.
Okay.
For polynomials, yes. There's a shortcut, but I'm not teaching you to yet.
Why?
You plug in 0 for
Same way Mr. Singh.
Yes, I went ahead and let 0 equal h.
How do you know when to let the dog off the leash?
When you don't get, say it, Johannes.
What?
How do you know to let the dog off the leash?
I was just saying
when you don't get 0 on top and bottom.
Yeah,
Or mostly on bottom.
And
Like,
now when you plug in
Yeah, whenever
3,
you won't get 0 over 0. So it's a judgment call each
and then
time.
you plug in 3 for x,
0 over
right?
0 or 0 on bottom?
0 over 0. 0 on the bottom is fine. That's just undefined. Undefined is not a problem.
You're on the top.
Indeterminate form, very much a problem.
I got that in my home. I got like 0 over 7 and 7
Well,
over
but
0
now
on
to-
Okay,
my-
well let's interpret this result. Alva's right, we haven't finished this one yet. So now, here's what we've discovered. For this parabola, we have a general derivative formula now. If f of x equals x squared minus 6, then f prime of x is going to equal 2x.
What exactly is prime?
The derivative.
Okay.
Now the derivative is used two ways in calculus. It's used to describe the general formula that gives you slopes of tangent lines, and it's used to describe a specific instantaneous rate, a specific slope of a tangent line.
But as of now, we don't need that. For
Well,
function.
Now, well, this one, we've got the general formula. The question was, what is the slope of the tangent line at x equals 3? So now I'm
6.
saying, what is f prime of 3, which is 2 times 3, which is 6.
That's what I'm saying, but you don't need the top, like, you don't need that function.
No.
Okay.
Really quickly, just picture this with me for a second. Here is x squared minus 6, okay? If you go to, let's see, square root of 6 would be less than 3. If you go to, let me draw this very well for this one. If you go to the point 3 on the x-axis, and you go up here, at this point there is a line barely touching the parabola,
Slopes.
and that line has a slope of 6. You know that graphically? If this represents a displacement, this is its velocity at this moment.
So what was that? Wait, the stuff we did yesterday, was that a word problem? Wait,
With a punch, yeah.
right.
Yeah, it was one long punch. And we found out that it was a,
Because this is a lot more simple, because we did a bunch of chunky stuff before.
yeah, we found a table, we used a table the first time to guess, then we used this to find it exactly, and we were trying to answer a specific question, how fast was the punch going?
Who'd you hit?
Ramsey.
How was it?
I didn't flinch once.
He didn't flinch. It was impressive.
How many meters per second is that? No, shush.
Inches per second? I'd have to check. I'm not sure off the top of my head.
care.
But do you guys understand graphically, aside from application, what you're finding here? You're
Yeah.
given a function.
This is actually really cool.
You're finding the slope of a line that barely touches it.
It's also really hard for how simple it is.
The result is?
Yeah.
Well, again, the shortcut makes it easier. I've never seen an AP Calculus multiple choice section, by the way, that did not have at least one question on it that was some variation on find the equation of this line. Actually find...
2x.
well,
But just y equals 6x.
well, this is y equals 6x plus b,
Yeah.
and then you'd have to find the y-intercept through some basic algebra 1
I'll
stuff.
just keep going down by 6. And
Well-
see if you actually hit like at a point first.
Yeah, it's a slope of 6, so you can do that. What you usually are taught to do is, on this parabola, this is the point 3, 9 minus 6. This is the point 3, 3. So what you would do is you would then say 3 equals 6 times 3 plus b, which gets you b equals
3,
what's
9.
18, negative 15.
Oh, I was close. I said
Yep.
negative 18.
So this is the line y equals 6x minus 15. And that's the line that actually touches this.
Did we just pass AP Calc?
No, you are now capable of passing one of the questions on the multiple choice section.
But that's what we were giving
What is that
Aren't
point
they
down there,
40
the
or
negative
something?
6?
Like 60?
No, that point on the graph, the one in the negative,
We taking it?
the negative
What?
y.
This one, yes, this is a y value of negative 6. That's my y-intercept. Interesting fun fact. This is how, by finding where this line hits here, closer and closer,
Just the same.
finding slopes of tangent lines closer and closer to this point, and finding x-intercepts, this was a way of finding out square roots without a calculator to any number of significant digits you wanted.
Ever?
Yeah.
1063.7.
Well, you'd be doing it for a while, but this would work eventually.
Wait,
Negative 4.
Do significant digits always have to, like, it has to be integers, right? Like, you can't say, I want to find, like, 1,614.4 significant digits.
Basically, no, but I was just reading recently about somebody who's working on the idea of Math for a while has been working on this idea of fractional dimensions, and so I guess I should say nothing's impossible.
What's the square root of negative 4?
Yeah, well, that won't work for that, except in terms of
2i.
Yeah, there'll be some ey's in there. Okay,
Hey, he's
I'm trying to look at one to see if I need to give you any more hints on the
Whoa,
algebra.
he's tall.
There's some x cubes where we haven't gone over. There's a couple that will challenge you because to go back and look at how we found other limits, because all I've done so far are polynomials. So for the last couple,
Let's do some circles. Oh crap, we have
well, hang on.
3 minutes.
I'm just going to set up one for you. Like, look, let's take a look at this. Maybe I can start this one. F of x equals square root of x.
Can you let us just try? Oh,
Okay, so that means f of x plus h
Is
is the
the square root of x plus
square root of x plus h. So what you're trying to find is
has to be, oh, okay, yeah, right.
the limit as h approaches 0, your f prime
x plus h minus square root of x.
minus root x over
h.
h. Now, what do we say to do if you wanted to get rid of radicals on the top?
Multiply by radical s,
Positive, right? Root x plus h minus
Hold on, you need to, like, go back.
plus, excuse me, like Alba just said, over x plus h plus root x. This is your a minus b, this is your a plus b, so what you're going to get is the
plus
limit
h.
of,
X plus h.
yeah, just x plus h minus x though, right?
Yeah.
Minus root x. Oh,
No, the root
x.
times
Yeah,
the root
you're
will
right,
get rid of it. Yeah, here's my a, here's my b, and then that's going to be over h times root x plus h plus root x, right? So I apologize for how quickly I have to do this, but this is x minus x, h divides with h, and what I'm going to get is the limit as h approaches 0 of 1 over, with all that's left on top, root x plus h plus root x.
Wait, do they put logs in this sometimes? Ever?
Not till next year, we won't get to that, but yes.
Oh, jeez.
Okay, the h goes to 0,
Yeah,
right?
you can let the dog off the
Let
leash.
the dog off the leash, so
2
h
root
goes bye-bye.
x. 1 over 2 root x.
Yeah, 1 over 2 root x is the derivative of root x.
So then you should plug.
Then you plug in whatever number you would give it. Yeah.
And then you take out the knife and
Wait,
stab
why'd you
yourself.
cross out the H? I'm sorry.
No, quite all right.
No,
there was a.
no, over here. Over
Why
here.
are we multiplying by x?
This one.
Oh, to
Why'd you
get
cross out
rid
the
of.
H there?
Oh, because I was letting the dog go off the leash. I'm letting H
Ah,
equals 0.
right.
Okay.
What if someone watched
Don't
this?
say anything yet. It was good times.
Wait,
weren't
you
they?
can leave the radical down there?
Did you take break off honors?
What if?
You can leave the radical down there?
Yeah.
Yeah, you don't rationalize it. You don't rationalize the denominator when there's a variable in it because this is not always irrational. When x is 4, this is totally reasonable. When x is 9, this is totally reasonable. Yeah, you don't bother rationalizing when there's a variable.
Is it doable?
This
Don't ask him.
gets easy. This is the hardest way to. This is the hard way to do it.
This is
He's
actually
right.
pretty easy.
Yeah.
I'm liking
Oh,
this.
you're gonna be so annoyed when you learn the easy way now.
The easy way.
There's an easier way. This is pretty nice. I like
Good,
it.
good. Okay, guys, 5th period's up. Are we done? Did we turn off?
No.
Okay. All right.
How do we actually